Right, so I can start now? So just let me know whenever I can start with the presentation so that I can go on.
You can start now.
Okay. So thank you, Mohini, and my apologies for the delay in starting the presentation. We had some glitches with the telephone lines because of which we've got delayed, but we'll just get started for the presentation. So I'm Kiran Darbar running the presentation. So the quick agenda slide. So we will start the presentation discussing what the messaging is and the different programming models we have on the messaging, and then how WebSphere MQ has evolved on this space, and how we can visualize WebSphere MQ and Message Broker as the universal messaging infrastructures. And the .NET platform, or MQ's existence on the .NET platform, is primarily focused from the client's perspective. So we will we'll first go through the MQ.NET stack. So we've called it as .NET stack, as we have layer of products available, or the layer of clients available on the .NET platform from MQ. So at that point of time, once after the MQ.NET stack, I'll hand over the presentation to Mr. Mallanagowda, who will cover it from the Message Brokers .NET Compute node and its integration capabilities side. So this is the quick agenda slide for today's presentation or the session. So moving on to the next slide. I'm on slide number 3 now. I hope my presentation is getting reflected across. So what is messaging? So messaging is a method of communication between software applications. Each application, henceforth called as a messaging client, connects to the messaging queue that provides facilities for sending, receiving of messages. From the picture that's there on the chat, messaging client A connects to messaging queue and sends messages, and the messaging client B connects to the messaging queue and receives those messages. Now this is how the messaging infrastructure helps to establish a communication channel via the messaging queues between these two applications. Now this communication can be synchronous or asynchronous. Now we call it as a synchronous when both applications are alive and sending and receiving messages, and it is asynchronous when A sends messages when B is not currently running or available, but then when B comes up, it can get all those messages or receive all those messages and the data. So that's where we call it as asynchronous. This is quick introduction about know what's messaging. I'm moving on to the next slide, which is slide number 4. Right, so we have two programming models in messaging. One is point-to-point, which is a typical example for application-to-application communication via messaging queue. There is a one-to-one relation between these applications, where sending and receiving application ensures that the message is delivered to a single consumer. So from the picture, application A sends a message to the messaging queue, and then B consumes it, and in return B sends a response back, which A gets it. So this is how typically a point-to-point messaging works, and hence we call it as a peer-to-peer messaging model. The next block is publish-subscribe programming model, which is a mechanism by which subscribers can receive information in the form of messages from the publishers. Now the publisher from the picture is the owner, which publishes message or relevant information in the form of messages onto a given topic. All the n number of subscribers which have subscribed to the topic can get that information. Now the topic can be anything. It could be a sports topic, and the publisher publishes message onto the sports topic, which all the n number of subscribers who have subscribed to it will get it. Now this is a one-to-many mapping, as we can see on the picture. Now there's a slight difference between a point-to-point and a publish-subscribe model, where in point-to-point the message is delivered only to a single consumer, or the consumer that is currently connected and gets the message. In case of publish-subscribe, the messages are delivered to all the n subscribers who have subscribed for a given topic. So these are the two programming models that we have in messaging. So moving on to the next slide, I'm on slide number 5. So, we have seen what is messaging and how applications can communicate in a typical messaging scenario. And then the programming models available for messaging. Now the third is, on the beginning slide we have discussed that the applications can connect to a messaging queue which provides these messaging facilities. In case of MQ, the MQ server is the message provider which provides this facility to send and receive messages. And the MQ clients are the applications which connect to Queue Manager or the MQ server for sending and receiving messages. So we have two models. One is a server model where client and server or the Queue Manager, the MQ Queue Manager exists on the same computer. And communication happens via inter-process communication, so which is faster, performance-oriented. And we call this as local or bindings mode of connection. And the another model is a client model where MQ Queue Manager is on an elsewhere computer and clients is on an elsewhere computer. And the client establishes a connection channel with the Queue Manager for sending and receiving these data. Now this is called as a client model. So just to summarize quickly from the MQ's perspective, so we have seen what is messaging, and then what are the different programming models available from messaging, and then what is an MQ client is, or MQ messaging client is. So I'm moving on to the next slide. I'm on slide number 6 now. So how did MQ evolve over the years? So we started with MQ version 1.1, which is with the assured delivery or point-to-point where a consumer will get the message. And then moving on to the multi-platforms, and we've continuously expanded and evolved, grown with the features and expanded with the products such as MQ Every Place, MQ Express, low latency messaging, where it is the throughput is most important, and then file transfer edition, which is for transferring files using MQ, and then MQ telemetric transport, which is for pervasive messaging or mobile space. And then the latest MQ version 7.5 is the latest available, which is named as MQ Advanced, which provides MQ Advanced Message Security, which is a security model, and then MQ File Transfer Edition, which is basically for transferring of the files under one roof along with the MQ messaging. So which is what is named as MQ Advanced, the current offering latest available in markets. So moving on to the next slide. So we've seen, mentioning as universal messaging approach. Now this is the slide which shows how MQ becomes a universal messaging backbone. So it has best delivery mechanism with choice of services, where it offers whole range of services on a single network from transactional to the low latency. A resilient integrity, and it has got resilient integrity and secure features with message queue for high resilience and message storing for high speeds, and choice of persistent strategies with a granular security for data and transport. It's highly available, provides strategies with software only for high availability, and as well as hardware based. And for ZOS, which is mainframe systems, we have shared queues, which makes it highly available. And then it's anything to anywhere, where you have choice of skills, choice of transports, platforms, and environments with MQ to work on. So this is what makes MQ as a universal messaging backbone, and then it's highly scalable. And hence, these are some of the targeted points that most of the business solutions look for, and MQ has, WebSphere MQ has all within, which makes it, as a universal messaging backbone. So moving on to the next slide. So this is a quick slide on the Microsoft .NET framework, which just gives quick overview and just introduces onto the .NET framework. So it's a software framework developed by Microsoft that runs on Windows operating system, provides class library and programming languages interoperability. Now, the applications that are developed on .NET are called as assemblies and they execute on common language runtime. And the common language runtime provides services such as security, memory management, and exception handling. The class library and common language runtime together, called as .NET framework. Two types of application modes available on .NET framework. One is managed, where the complete memory management, exception handling, security are handled by CLR, and application runs entirely under the control and scope of CLR. The other type is unmanaged, where the parts of application can execute outside CLR scope. For example, calling a C API, I do a platform invocation and call a C API. So this is, and from MQ we have support for both managed and unmanaged modes. Where in managed, the complete messaging client or the MQ interfaces are implemented in C# language, and in case of unmanaged, we have .NET classes delegating the calls to C clients or CMQI, MQ interfaces. So that's how the managed and unmanaged supports exist as of today. So this is a quick information on .NET framework, but in case you want to get more information, you can reach out to the Microsoft website. They have lots of information there. So moving on to the next slide. I'm on slide number 9 now. So this picture gives a complete MQ client portfolio. So at one corner, towards the top left corner, we have MQI, which are the native MQ interfaces currently available with C, COBOL, etc. And then we have the C++, .NET, and Java languages existing as OO classes for MQI. So we have object-oriented classes on top of this MQI, but written in for .NET, they are written in C# language. And then the other programming model is JMS, MQJMS, which is based on JMS specifications. And exactly for the non-Java world, we have another programming model, which is XMS, which is implemented based on JMS specification, but provides messaging API in C, C++, and C# on .NET platform. So this gives a quick picture on the MQ client portfolio. More on the .NET classes and XMS we will be seeing in the slides to come. But these are the different programming models we have as messaging clients available from MQ. So moving on to the next slide. I'm on slide number 10 now. So this is the zoomed in image. The slide previously has shown the complete MQ clients portfolio, but the current slide shows you the zoomed in image of the MQ.NET stack. So we'll go from bottom up. So we have MQ Queue Manager, which is the MQ server, and then we have MQ.NET interface, which is the OO classes on MQI, which are written in C#. And then on top of this MQ.NET interface, we have XMS.NET, which is based on JMS specification. Now, on top of XMS is what the MQ's custom channel for WCF. So this is how all these clients are layered in MQ.NET stack. As discussed in the previous slide, we have two types of connection modes. One is local bindings, where the client and the server exist on the same computer, and the communication happens via inter-process communications. And then we have client connections, where a communication channel will be established with the queue manager for sending and receiving messages. Now we have two kinds of connections here. One is unmanaged connections, where the .NET classes delegates calls to C client, and we have another mode of connection, which is managed client, where the entire MQI is implemented in messaging client is implemented using C# and which executes completely under the control of or under the scope of CLR. So which gives you all the advantages, allows you to fully leverage the advantages that CLR provides, such as security, exception handling, memory management, and so on and so forth. So this is the zoomed in image of the MQ.NET stack. Now each of these clients or each of these layer has got their own importance, which probably we'll discuss in the slides to come. I'm moving on to the next slide. I'm on slide number 11. So we will go on layer by layer and see how each of these help the business. So to start with, MQ.NET classes, which are based on MQ.NET or MQI, MQ interface. So in a nutshell, they are the standard MQ interfaces made available from OO classes and popularly known as base.NET classes. The purpose of this interface or these classes is to provide straightforward and sophisticated messaging for the applications. And this is the messaging API implemented in C#. So it's a very quick messaging API. So how to send and receive a message to the MQ? It's very quick. Just create a queue manager class instance, which is MQ queue manager class instance, which actually establishes a connection to the MQ queue manager for accessing the resources, which are the messaging queues or the topics under the queue manager. Now create another instance of MQ queue or MQ topic, which actually accesses the messaging queue or the topic destination under the queue manager, and then create an instance of message which can carry some the data or the relevant information that you want to send across, or send it to the messaging queue for the receiver applications. So just instantiate these three objects. Send is to send the message, and then receive is to get the message from the messaging queue. So typically how a message will look like. So I've got a quick rectangular boxes there. So this is how the message will look like. We have an MQMD, which is a message descriptor header, which is and then an RFH2, which is to allow some of the user-defined properties to be carried on as a header, message header, and then payload, where the actual data or the information for the exchange between the applications can be added. So this is how a message object will look like. So moving on to the next slide. I'm on slide number 12 now. So this just put some of the features that base.NET classes provide. So it supports both point-to-point and publish-subscribe programming models, and it can access queue managers on multi-platform, which is Windows and as well as non-Windows platforms, including ZOS and System I. It supports distributed transactions, client automatic reconnection, where in case of a failure, the client automatically reconnects to the queue manager, and it also supports multi-version MQ accessibility, socket sharing, where one socket can be shared by multiple connections, and it is completely interoperable with XMS, JMS, and other WMQ applications, and supports channel definition tables for reuse of the resources or accessing resources at runtime. So moving on to the next slide, I'm on slide number 13. So when to use base.NET classes. So simply, these are the simple and straightforward APIs for publish, subscribe, or put or get messages. So whenever you want to be entirely on the .NET world and leverage the .NET capabilities entirely, and yet have a simple and straightforward way to send and receive messages, these are the APIs to go. And then whenever you want to access low-level message structures and add extra headers to the messages, again, these are the messaging. This is the messaging APIs to go. And using base.NET classes, you can, or MQ.NET classes, you can actually inquire or set some of the MQ resource attributes. For example, queues, the maximum depth of messages a queue can hold, and some of the other configurable properties that can be set programmatically using these MQ.NET classes. And this is the core .NET developer-friendly API. So as discussed, developers don't need to know anything about JMS specification. We have XMS, which is based on JMS specification, but this API is purely on the for the .NET world, who doesn't want to use anything specific to Java or JMS, MQ-JMS kind. So these are some of the cases to use base.NET classes or the MQ.NET classes. So moving on to the next slide, I'm on slide number 14 now. So we will now look into the XMS.NET, which is popularly known as, or officially known as IBM Message Service Client for .NET. Now this is created by IBM based on JMS 1.1 specification, and it's a messaging-oriented middleware API in C# for messaging. And again, the purpose is to provide straightforward and sophisticated messaging. This is available with MQ version 7.0.1, and it's fully integrated component with MQ. So the XMS objects, or XMS application is a system comprised of XMS clients and at least one XMS or JMS provider. And the XMS or JMS provider is the message-oriented middleware that provides the facility to access and then send and receive the messages. A producer and a consumer, so who can send and receive the messages. Moving on to the next slide. So XMS features. So it supports all the features that base.NET Classes supports, which we have discussed on slide number 12. So one of the previous slide. On top of it, it also has got some of the other features like it's a cross-language programming API where it's a set of high-level classes which are defined from the unified domain on JMS 1.1 specification. And these are the same set of APIs available from C, C++, and .NET Client. And these are the same set of APIs using which you can access either MQ or WebSphere Application Server or WebSphere Message Broker with a very minimal or no application changes at all. And it supports 5 message types, to name bytes message, stream message, map message, object message, and text message, each of it carrying its own appropriate reason to use for. And then it supports decoupled administration where applications are loosely coupled to the resources by looking up, by looking them up at runtime on a Java naming directory service. This is exactly how it works in JMS as well. And the objects or the resources that are created on the Java naming directory are completely reusable for XMS objects. I mean to say the resources that are created for JMS on LDAP or file system context or on a WebSphere application server JNDI, they can be reused or they can also be used by the XMS applications. And it's interoperable with JMS and other MQ clients. So moving on to the next slide. XMS when to use. So whenever you want to leverage JMS specification or JMS messaging middleware API from non-Java applications, so you want to have JMS kind of programming but from non-Java application or non-Java world, then XMS is to go. And easily migrate between the messaging servers and the transports. So as discussed, the single API from XMS you can use to talk to WebSphere application server or message broker or message queues. So it's the same API, same application, but with minimal changes in case you are connecting to the resources or the servers programmatically, with no change at all in case you are using JNDI. Provides higher abstraction in programming model, and XMS is to go whenever you want to reuse existing JMS skills. So these are some of the cases where you want to use IBM Message Service Client for .NET. So at this point, I will just give a quick pause and summarize between base.NET classes and XMS.NET. So base.NET classes are for one particular use where you want to have a very quick API which is purely .NET friendly and allows you or gives you a .NET friendly environment to access the queue manager or enables developers access to the MQ queue managers. On the other side, XMS is again on .NET platform but helps you or enables you to reuse your existing Java or JMS skills connecting to the MQ queue managers. So this is the clear differentiation between these two APIs available from MQ. And before we and one another point is, so this is the messaging API available, and this can completely integrate into your existing .NET application, wherein which both XMS and base.NET classes supports distributed transactions, and the MQ, the process that involves MQ operations can gel up with the other operations related to the other resource managers. For example, like SQL Server database. So you want to do some database update. At the same time, you want to do some MQ operations as well. So you can club both together in a single application and have them run under single transaction scope. Also, you can enable the automatic reconnection where, in event of failure, the clients can automatically reconnect to the queue manager. Not just this, but you can also have your integration capabilities with other Microsoft products such as Dynamics AX and Dynamics CRM, where in a single application you can do the messaging operations as well as you can do the database or CRM or the other operations you would want to do with the .NET client or the .NET on the .NET platform. So this is how the MQ.NET clients helps you to build applications that not just do the messaging operations but can also become part of your existing applications, which involves accessing a lot of other Microsoft services. So moving on to the next slide. So I'm on slide number 17, which is MQ's custom channel for Windows Communication Foundation. So Windows Communication Foundation provides a service-oriented architecture on Windows platform, which is to provide broad interoperability, reliability, security, and transactions, and yet allow you to build SOA kind of applications. And the work IBM is doing on using the MQ with Windows Communication Foundation is an example on how SOAP over JMS can be used outside Java. So the MQ's custom channel for WCF layered on top of XMS, which provides JMS kind of messaging facility, so which helps you to build a SOAP over JMS request response over the WCF transports. So moving on to the next slide, I'm on slide number 18, so which is WCF MQ's custom channel architecture. So if you look at the architectural diagram, so MQ exists as a transport within the WCF architecture. So wherein which the WCF client can create a request in the form of SOAP over JMS by accessing the MQ resources, messaging queues or the topics, and then send the request onto a messaging infrastructure or to the queue manager. The WCF service on the other side running accesses the messaging queue, consumes the request, processes it, and then gives its response to the same queue from which the WCF client can pick up. So this is typically how a WCF client and a service application run using the MQ as a transport service. And why MQ as a transport service? Because of its quality of service, and which includes reliability and a lot of other features that MQ comes in with. And this is currently available with MQ version 7.01 and fully integrated into it. So that's on the MQ's custom channel architecture. So just a quick summarize. So we have seen what is messaging and programming models, and then we've discussed about MQ .NET client, MQ.NET classes, and XMS.NET classes, and WCF. So this is how the clients, we have different clients available from MQ for this catered use on the .NET platform. So one is to use a complete .NET friendly API, which can be used purely within the .NET platform, and one which provides JMS kind of JMS specification API, which enables you to reuse existing messaging service skills, and then WCF, the custom channel on WCF, which helps you to build service-oriented applications on Windows platforms, leveraging MQ's quality of service at the same time also using WCF advantages. So that's about from me on the MQ's perspective. So at this point of time, I'll hand over the presentation to Mallanagowda, who will be running it through the message broker's perspective. Thank you.
Thanks, Kiran. Mohin, can you give me the presenter access? I hope you all see my screen now. Thanks, Kiran. Thanks, Mohini. So let's begin. So far we've seen the .NET capabilities offered by WebSphereMQ. So now let us look into the .NET capabilities offered by WebSphere Message Broker, which is a key product, key middleware product from IBM. In the next few slides, we'll see a quick introduction about WebSphere Message Broker and the new features available in the latest release, then detailed .NET features provided in version 8. Okay, so let's begin. So WebSphere Message Broker is an enterprise service bus offering from IBM. Its primary purpose is to enable connection between different environments which might use different network protocols have a different interface styles and which have a different formats of data representation. Okay, WebSphere Message Broker allows you to develop integration applications in many ways using the programming styles and different languages. Okay, we support Java, we support SQL, we support PHP. With version 8, we added .NET, which we'll see in detail in the coming slides. Okay, WebSphere Message Broker is available mainly in 3 components. We call it WebSphere Message Broker Toolkit. It's used for application development. Okay, so developer can develop their message flows. Then there is the Message Broker Runtime. It's for running the application. Then there is a third component called Message Broker Explorer, used for system administration. Okay, moving to the next slide. So now let us see the key features available in Message Broker version 8. So basically, we have made significant changes in the application development by introducing a new style of development called applications and libraries. The applications and libraries provide a new way of creating and managing resources when you are developing and deploying applications, and during operational management as well. Okay. Then there is the improved graphical mapping. The mapping node or the mapper, it allows you to generate the output message by using some of the elements available in the input message, as well as you can interact with the database. Okay, we have added a few new patterns. Basically, they are called the technological patterns. The key ones are the work-light and the .NET integration one. The Message Broker provides a lot of tools for administrators. The key one are again the REST interface for the operations and the administration. Then we are providing the web admin tool, so user can use the browser to manage the browsers and execution groups or the flows. Then we are providing a record and replay capability, which helps to speed up the development as well as the troubleshooting in production. Okay, going to the next slide. I'm on slide number 21. So now let us see the .NET capabilities we added in version 8. Okay, so this is a key feature added in version 8. So why .NET? So prior to this, the integration mechanism with the .NET application was through web services only, and there were a few limitations, and because of that, the .NET applications and Message Broker applications couldn't be integrated very well. And we also want our customer to get into Microsoft capabilities, so that they can use Message Broker applications to talk to Dynamics or Sharepoint, or they can use Visual Studio for development. Okay, so if you see the screen, there was a survey done last year, and the languages that are used by many of the developers are C, C++, and C#. Okay, see, the .NET is a very popular language, language used by many of the developers. Okay, so now moving to the next slide. So what we have done is we are providing a extremely tight language integration with .NET environment. So what we are doing here is Message Broker integrates basically hosting a CLR environment within the Message Broker itself. So it helps Message Broker to run any of the programs written in any of the .NET languages. Okay, so you can create your own .NET Compute node by dragging and dropping the assembly that is written in one of the .NET languages, or even you can call the .NET a procedure from an SQL language itself. Okay, so So it's a very tight integration within the with Message Broker, and also we are providing a tightly integration with Visual Studio. So as you know, the .NET developer use Visual Studio for their development purpose. So we don't want them to switch to any other IDE. So for that purpose, so Message Broker provides certain templates so that it helps developers to quickly develop their applications. Okay, I will show you what are those things in the coming slides. So one of the example I have put it on the screen. If you see the bottom of the flow structure at the bottom of the screen, so you can it shows basically how you can integrate or how you can call a COM application from the message flow. Okay, so you get a web services request from your web services client, and then you may want to call a web service, another web service, by using the COM application's input, and then you can send the response back. Okay, so moving to the next slide. So also we are providing a first-class .NET API support within the Message Broker. Okay, so you can write your transformation logic in any of the .NET languages like C#, VB, Foxtrot. Okay, it's all supported. So if you see the screen, I have shown what all things you can do with these features. Okay, you can invoke the Dynamics CRM, or you can call the COM application, or even you can use the .NET Node to integrate with your Kix application or with the MQ applications as well. Okay, on the .NET Node, so basically we have introduced a new node called the .NET Node. It is quite similar to the Java Compute Node or a ESQL Compute Node. So it has an input terminal and it has a couple of output terminals as well. Okay. So moving to next slide. So we are giving a tight integration with Visual Studio. So what happens is, if you are using a .NET Node in a message flow, you can just double click to open up the Visual Studio, or you can open it, or you can even open it from the ESQL. So, or what you can do is you might have developed the .NET assembly already. So what you can drag and drop it to the message flow editor. So it asks you whether you want to create a .NET node or whether you want to create the ESQL node, and even it takes the .NET procedure which has to invoke the path for the .NET assembly. So it all takes care of that one. Okay, so it's that much easy. We are moving to next slide. So I'm just showing how this can be done from the Message Broker toolkit. Okay, so you can double click on the node itself, or you can right click on the node and open the Microsoft Visual Studio. So what happens next is, so you will see when you are creating a particular project, you will see these three templates. Okay, whether you want to create a new message, or whether you want to work with the existing message, or whether you want to do some filtration. Okay, so even we provide a template code that helps you to start on. So there is a class called MB. So there is a class called MB message which helps you to work on the input message, and also you can work with the local environment structure. You can work with the environment structure. You can work with the input message that is provided to the .NET node. Okay, so moving to the next slide. So also we are providing the .NET sample. If you are new to Message Broker and if you are new to a .NET world, then you can use Message Broker sample to start with. Okay, so it explains how you can use the three templates we have provided with the product. So creating the message, filtering the message, and modifying the message. The sample shows what all the capabilities you can do within that node or within the class. So moving to next slide. So let me explain how you can integrate now Message Broker and CRM, the Dynamics CRM. Okay, the Dynamics CRM is hosted on one of the Windows servers or the IIS servers. Okay, so probably you want to create accounts to manage the CRM portal, right? So if you start creating accounts manually, it's going to take a time. So probably you want to automate it, and you may want to use Message Broker there, right? So in that case, so you can make use of this new feature we have added in Message Broker. Okay, so probably the input point is say WebSphere MQ application, and again the endpoint is a WebSphere MQ application. In between, you want to use the .NET class library. So you create a flow using the MQ nodes and the .NET nodes, as I have seen on the bottom of that screen. Okay, you send the message. You provide the input message details that you want to do it on the CRM portal. Suppose it's creating an account on the CRM portal. Okay, the message is given. So what you need to do here is you have to create WCF assembly by invoking a CRM service. Okay, so there is a documentation provided in the CRM SDK. So by going through that, you have to create a CRM assembly, so that will invoke a particular entity on the CRM portal and provides you the appropriate response. Okay, so you do that, you build the assembly, then you include that with the message flow that you have developed in Message Broker, and you deploy it on the Message Broker runtime. So when the message is sent, going to next slide, you will see account gets created on the CRM portal. Okay, just one example I have taken here, and it shows how easy it is. Okay, so you see there the account gets created, and also you get some response that you can send it back to the client. So with this feature, basically it allows the integration mechanism between the WebSphere Message Broker and .NET. It simplifies the integration between Message Broker and .NET, and also you can work with the Microsoft Office, or you can work with the com applications, or you can work with the Sharepoint, or any of the applications available in .NET. Okay, so with that, I conclude my presentation. Hello, Mohini, we are ready for questions, if there are any.
I would request the audience to kindly please send their questions if you have any. Can you see the question, Kiran? I have assigned a question to you.
Right. Yes, I can see the question. So am I audible?
Yes, you are.
Hello?
Yeah, you're completely audible.
Yeah, am I? Okay. So the question is, how is message delivery assured in web service? Right. So the message, as we've discussed in WCF slides, so the web services uses messaging infrastructure as their transport channel. So wherein the web services puts a request as a MQ message or a JMS message onto the messaging queue. And then the service which is running on the other side can pick up this message, okay, and can pick up this message and then process it and provide the response back onto the same messaging queue. Now the web services client can can pick up the response from the messaging queue. So the underlying transport channel being MQ. So the point I would like to bring out here is web services. The transport channel that the web services are using are MQ, and the reliability and the other quality of services which are coming with MQ are available for the web services client and the services. That's how reliability and message delivery can be assured in case of web services. I hope I was I have answered. If not, you can ask me for further clarifications.
There's another question, Kiran.
Yeah, I'm just reading through it. Right. So the second question is, how can we ensure message delivery is safe and cannot be intervened and shall be private for peer-to-peer communication? Right. So in case of peer-to-peer communication, we have a producer and then a receiver, which is a consumer connected to the queue. Now, producer and consumer both have secured layers by using the security while establishing a communication channel to the queue manager. Now, this secure layer which the producer and the consumer establish will ensure that the messages are not intervened by the third parties or anyone other than the producer and the consumer. So the security support which is existing with this with the MQ clients is what will help you to make messages or the messaging secured in case of application communications. And the third question is, by MQ, do you mean MQ nodes? So this is the third question. So, and I think we have discussed about two products here. One is WebSphere MQ, and the other is WebSphere Message Broker. Now, in case of WebSphere MQ, we have messaging queues and topics, and .NET application can send messages directly to the queue and also receive the messages directly from the queue. Now, the queue manager can be on Windows or on non-Windows platforms. But in case of Message Broker, we have MQ input and MQ output nodes. So the messaging on Message Broker happens via MQ nodes, MQ input node and MQ output node. So this is what it is. I think, and for the web services, when we are using a web services URI to access the service URI will contain the resources to which the client can connect to or send a request response or get the response from. Now this URI will contain the destination endpoints to which the request should go and the endpoint from which response can be received. And that is how the web services client can have MQ resources as its endpoints. Malu, you want to add anything from the web services point of view for this question?
No, I think you answered it. And in case of web services, the web services capability provided in Message Broker, we provide all security mechanisms like AWS security, and for the authentication, we support the SAML, we support LCHOP, we support the Kerberos as well. Okay, so we are with the W3C standard specifications. We follow all the W3C standard specifications on the web services point of view. However, if you are using the WCF web service capability on the .NET side, so it's all on the .NET side. Yeah, go ahead.
All right, thanks, Madhu. All right, so I'll read out the next question, which is on the screen. So again, so I think this is from the same person. So asking more on what if the endpoint is down and will the message get lost? All right, so again, just reiterating whatever we've discussed a couple of minutes ago. So client and the service are accessing one MQ messaging queue. So for example, if the client is not active, client sends a request for some information and client goes off. Client is not active at that time. But if the message reaches the messaging queue and service is available running and takes the message, processes it, and gives some response as part of this web service invocation, this response message will come to message queue and it will reside there. Now, when the client comes back, it can access the same message queue, get the response, and then act accordingly. So the message is not lost as long as the message is available with the message queue. But if the client goes off or the server goes off even before the message gets onto the message queue, then yes, there's a chances of the message being lost. But as long as the message is there with the message queue, the message is not lost, and that is available for the client or service process, processing it. All right. So the another question on the list is, can it be possible to create bidirectional MSMQ? If yes, can a single MSMQ can be used for a client and a server? I'm so sorry. So the current presentation or the session that we have ran through is for IBM WebSphere MQ. So we have not covered MSMQ as part of this session. So probably I'm sorry to skip this question. So so if it is, so it's basically on MSMQ, but it's outside the session scope. The next question on the list is, does .NET MQ support ordered delivery? That's right, yes. So it supports ordered delivery where you can create message groups and message sequencing. So you can give sequence number and you can tag them as messages in a group. That's when you get all the messages in a group in a sequence order. For example, I name the group as my group, and then say 100. I put 100 messages as part of the group with order starting from 1 to 100. So when I access these messages, as a group, I get all these messages in a single order, right? So that is how the order delivery is supported in MQ.NET. I hope I've answered it. So if you need further clarifications, you can put a follow-up question. The next question on the list is, you have chosen C# for this project delivery. Why not Java? Java is considered safe for most applications present in the markets. All right, so we do have MQ Java. So the current session is primarily focusing on .NET's availability, MQ.NET, MQ's availability on .NET platform. MQ and Message Broker do have Java clients and Java existence on Java platforms. So it's not that it's only available on .NET platform. We do have Java clients and Java existence on Java platforms. But the focus of current session is just on .NET platform and its integration capabilities on .NET platform. So that's the last. That's the one last question on the screen I can see. So.
Well, those were the only questions we had. Thank you so much for the insightful presentation. I'm really thankful to you both for conducting this webinar, and I really apologize from our audience for the technical glitches that happened today. The recording of the session
Right,
would
and
yeah.
Yeah, one just last point I would want to make is, for the entire audience, please feel free to get in touch with us on our email IDs. Probably they are available on the webinar page. For any questions on MQ or Message Broker, feel free to get in touch with us. And if there's any follow-up or more detailed knowledge, current session is purely an overview on what's available and how it can be used. But if you need anything in deep, probably you can get in touch with us and we can see how it can be served. Thank you. Yeah, you can please carry on, Mohini. Sorry for that.
And the recording of the webinar would be available on tech.com by tomorrow morning. Thank you all. Have a great evening.